Yeah, welcome to the week 2 of environmental engineering course offered by NPTEL and IIT Roorkee. So I am Mansi Tripathi. I am TA for this course and will help you, and we are here to help you to solve assignment problems as well as the problems in the upcoming examination. So the pattern is like every week, whatever the course sir has covered, whatever portion he has covered, we will solve some questions on that, and in case of any doubt you can ask me in between or at the end of the session, and you can ask me questions in between two sections. Means I'm conducting on Tuesday, there is one another person who is conducting on Saturday, I guess. Then you can ask, you can reach out to us for any doubts. So I'll share my screen, then we'll start solving some questions. So, once again, welcome to the Environmental Engineering Week 2 problem solving session. So, in this session, basically what we covered is about the study of component, how to describe, like if in any reaction, how do you find out what is the component, what are the species, and based on that species, we write different component equation so that we can find out the concentration of any particular species. So this was the first thing. Second, we learned about reaction kinetics. So there are three types of reactor which were explained. Batch reactor, I'll write. Batch reactor. Here there is no inflow or outflow, just we are doing the reaction in a particular batch. So one example for this will be sequential batch reactor, which is used in a wastewater treatment plant. Second reactor is completely stirred tank reactor. Here there is some inflow coming as well as or continuous flow stirred tank reactor, and there is some outflow and there is some reaction going on. So this can be example of ASP, or if we are talking about natural examples, it is lake. In any lake, there is always some flow coming, there is always some flow going, even there will be some evaporation, and there will be various reaction going on inside, because there will be microorganisms, they might be degrading some organic matter or they might be releasing some organic matter. So somehow some reaction is going on which is either increasing or decreasing the coming pollutant. Third is plug flow reactor. Plug flow reactor, here the basic thing is about length. So river is one example. If we are putting any pollutant at this point, what is the concentration at this point? So it depends upon the length, ki how in this length the pollutant is degraded. Mostly it will be degraded if we are talking about a river. So these were basically three types of reactor. We learned about equations also, parallel equation as well as sequential equation, and how to write component equations for such chemical reactions. So this was the basic outline of the course. I hope you have seen the video lectures, so we can go on with the questions. So this is the question number 1. Consider the dissolution of sodium bicarbonate, that is NaHCO3, in water. Species has equilibrium for the above dissolution are these. These are the species. Which of the following groups can be chosen as component for formation equation? Okay, when we talk about formation equation, we want that a particular species should be made by that like when we write an equation, it can be hypothetical also. It does not need to be a real equation. It can be hypothetical equation. So we have to find out which of these components may be used as a formation equation. So how this thing is dissociated? NaHCO3. So first dissociation will be Na plus HCO3 minus. Then HCO3 minus, how it is dissociating? H plus CO3 minus. CO3 2 minus. So this is how it is dissociating. So from this, these are the given species. Now we need to formulate the formation equation. So please try to solve this question. We will see the solution in a minute. I hope you have got the solution, and so this is the correct answer. Okay, and this is the reason for the correct answer. Now I'll explain the way sir has explained how to solve such questions. So we are seeing these species are there. Then let's see how they will be formed. Let's list out all the species. So for making H plus, what do we need from these species? H plus is enough. For OH, we need just OH is enough. For H2CO3, we will need 2H plus CO3 2 negative. Here we need H plus CO3 2 negative. For carbonate, we need just carbonate, and for sodium, we need just. So we are missing out one species, which is itself the salt. So here, what do we need? We will need Na plus H plus CO3 2 negative, or we will need Na plus HCO3 negative. Okay, so we can see the maximum number for making all these components, like all of these. What do we basically need? H plus, sodium and CO3. Okay, and as you can see from this example, for this is also the solution. So if we are looking, if we are looking at this point only, OH, H plus and Na, then there is no carbonate. Okay, so these cannot be used to make all these equations. And if we are looking here, in this, there is no sodium. So this option also cannot be used to make all the components. Here there is no carbonate and here there is no H plus. But these equations, by adding or subtracting, we can make out all the components. So that is why B and D are the correct answer. I hope you understood the solution. If there is any doubt, you can ask. Or we'll move towards the next question. So this section basically this week was all about these things only. If these basics are very clear, then there won't be any problem in the subsequent questions. Yeah, any doubt?
I have a doubt, madam.
Yes.
The question is both B and D both are correct.
Yes.
Correct answer.
Yes.
So
Yes.
why these two are correct, others are not?
See.
What is the reason behind that?
Yes. If you see option A, like you are seeing all these species, right? So when you look all these species, in case you want to make H plus, you need just S plus. You want to make H2CO3, you need these things. Okay. So if we look at option A, let's say we have OH, H plus and Na plus. Will you be able to make this component out of this? If I give you one solution in which only these things are there, Na, OH and H plus, will you be able to make NaHCO3? You tell me. Like,
Yes.
see, if I am giving you a glass of water, I am putting sodium, I am putting OH and I am putting H plus. So there is no carbonate. So will this reaction will be able to work? Will you be able to work out this reaction? There is no carbonate. That's why option A is incorrect. Because
Yes.
yes, and same in
I
option
understand.
C. Yes, and same in option C. There is no sodium. From option C, you can make bicarbonate. You can make carbonic acid, that is H2CO3, but you cannot use sodium. There is no sodium. If there is option of sodium, then this question will be correct. Then this option will be correct. But others, you can make anything. I hope you understood.
Yes, I understand.
Oh, thank you so much. So we'll move towards next question. Next question is, sodium acetate is dissolved in water to undergo the following reaction. So here we can see the species and we can see the component as well. Choose the correct option for total concentration of component. We want to make the total concentration of component. We want to make H total, sodium total, acetate total and again H total. So there are 4 options. Please try to find out the correct answer. I'll give the solution in a minute. Please try it by yourself.
Yes, madam. The D is the answer, I think.
We'll see. Correct option is B, C and D. And how? If we want to make sodium, so this question is very simple. Like how you can do it, just look at this species and you want to put sodium total. Just list out everything that has sodium. In this case, only sodium has sodium. Okay. Let's talk about acetate ion. So list out everything that has acetate ion. So when you look at this list, AC has acetate ion and HAC also has acetate ion. So just write it down. AC negative plus HAC. And when we want to look at HT, means now you want to list out those things which has hydrogen. So while looking at this equation,
Madam, I have a doubt.
yes.
The question is, so if you choose the 3 questions are correct, so why not A1 is correct?
A, like if you look at A, we want to see H plus. This has H plus, correct. This also has H plus. Here also, but here H plus is not there. Here H plus is not there, and here also H plus is not there. That is why. If you compare A and D, so this will be the correct. If you want to write equation for H, then only list out those things which has H. So if we look at this species, here we are getting H, and here we are getting H. So that is why option A is not correct. Rather than
Yes, it's right.
okay. I hope you understood.
Yes, I understand.
As you can see in
So on the
the
basis of species, we can choose the components.
yes, 100%.
Acha, okay.
Yeah. What's your question is only asking. Your question is only asking total concentration, so don't need to subtract. Is that correct? No. Actually, if you will subtract it, let's say this is 5 millimolar, this is 10 millimolar, and these are 2. So when you will subtract it, the overall thing will reduce, right? So we don't want that. We won't get H total fully. So that is why it's not like you don't have to subtract it. You have to just add those things which has that particular species. When we talk about H, you want to add everything that has H. When we talk about acetate, you want to add everything that has acetate. But for this OH, there is no problem. Okay. So I hope you understood this thing.
Yes.
Okay, we'll move forward to the next question. It's very good. Like, if there is any doubt, please ask. It will be very helpful in the examination, because first of all, few 2-3 weeks is just about basics. If you will learn this thing properly, then in the next section, when you will see acid-base problem, precipitation, solubility, these things. So these basics are very, very, very important to reach to that. Yes, moving towards next question. A sequential reaction occurs in following 3-step process. So this is a sequential reaction. Here K1 is 100 times of K2, which is equal to K3. So which is the rate determining step? So as we know, rate determining step is the slowest step. So please let me know which among these is the slowest step. This is very simple question.
I think first step is the very slowest step.
First step you means from A to B?
Yes.
C.
Is it correct?
No, it's not. Answer is option B, because when you move from A, like just take an example, there are 3 cars. Okay, this car is moving at the speed of 20 km per second from here to here, A, B, C, and from this equation we can see K1 is 100 times of K2. So first car is moving at 20 km per hour. Then the second is, which is very slow. Second is moving at this speed. And third, so K1 is equal to K3. So third is also moving at good speed. Okay, so this is basically what it is written. So which one is the slowest? Which one is moving slow? B. Okay, so that is why from B to C,
Okay.
this reaction is the slowest. Okay, now this is K3, this is K2, and this is K1. Let's say these K1, K2, K3 are talking about the speed of the cars. So that is why the second step is the slowest. Moving towards next question. Which of the following statement is are correct? Consider given reaction below. See, all these questions have already, like, they were from your previous or before that examinations. So that is why all these things are written, that marks will be given only if all the marked options are correct. So this is the way it will be done in the examination also. Like, if two options are correct and you are choosing one option only, then you won't get any marks. Okay, so you have to, in theoretical question, you have to be correct, very precise in all of your options. Then only it will be clear that your concepts are fine. So there is a reaction from A to B, and we are talking about reversible, irreversible reaction as well as rate determining step. So this is a theoretical question. Please try to come up with a solution. Yeah. You also want to try, Manoj? Okay, I'll explain what is reversible and irreversible reaction, so that maybe it will be easier for you to find out. So this reaction is moving in both the direction. Let's say when A is converted from, when this reaction is considered forward direction, we are converting A to B. Let's say rate is RA, and when we are converting from B to A, rate is RB. If it is irreversible reaction, irreversible means it is not coming back, then I am telling you answer also, RA will be so much greater than RB. Okay, and if it is reversible reaction, then there may be chances that one is greater than B or one is lesser than B, but there won't be much difference. There will be difference of, let's say, 2 times, 3 times, but there won't be difference of 100 times. So that is the difference between reversible and irreversible reaction. And this you can very easily tell. So we'll see the solution. So correct option is A and C. So C option is very clear. The rate determining step is the slowest step. And for option A, for the reaction to be irreversible from A to B, RB has to be much greater than RA. So I think I wrote it opposite. RB means formation of B and RA means formation of A. So that is why formation of B should be much greater than formation of A. Okay, these are the formation quotients. So it's my mistake. I should write this very clearly, that this is formation, rate of formation. Okay, I'll explain it again. See, there is a reaction which is going from A to B, and it is also coming back. So RB is the rate of formation of B, means how fast B is forming, and RA is the rate of formation of A, means how fast A is forming. So when we say the reaction is irreversible, means it is not at all coming back, means A is not at all forming. So how is that possible? Only when the rate of formation of B is much greater than rate of formation of A. Okay, So that is the only way when we say reaction is irreversible. So if you want me to give you an example, I'm unable to think of anything right now. Maybe in due course I'll think something. I'll explain. Okay, we'll think of it. But I hope you understand this concept.
Yes, I understood.
When things are moving forward in a faster pace than backward, it is called irreversible reaction, because it is not coming back, it is not reversing back. We'll move towards next question. I'll clear the screen so that you can see the solution. Anyway, I'll share the slides. So question number 5th is 1 gram of solid calcium sulfate is added to 1 liter of pure water. Calcium sulfate, it is blue in color, so we are putting it into the water. Some of the solids then dissolve according to the following reaction, and we know the equilibrium constant, 10 raised to power minus 4.85. So this is dissolving. So when we add calcium sulfate in water, the water turns in very good blue color, a very bright blue color. So this is the reaction, and equilibrium constant is also given, that is 10 raised to power minus 4.85. So how do we write equilibrium constant? Ca2 plus SO4 2 negative and CaSO4. When this thing is solid, anything is solid or liquid, we consider the molar concentration as 1. So now this is 1. So what we come up with? 10 raised to power minus 4.85, which is given here, is equal to Ca2 plus SO4 2 negative. Sudarshan, could you please turn off your mic? Okay, I muted you. Okay, so this is one equation. Now you need to find out the concentration of Ca2 plus at equilibrium is 10 raised to power minus x. I have given you this equation very nicely. It has made your solution very simple. You have to find out the value of x correct to 2 decimal place. We know sulfate, that is 10 raised to power minus 1.87. Please use calculators to solve this question. We have this, we know this concentration. It's very simple to find out this concentration. Please try to find out and let me know the answer. Use your calculators. Be very careful, you are using natural log or exponential. Solve this question. It's very simple. 10 raised to power minus 4.85 is equal to Ca2 plus multiplied by how much it is given? 10 raised to power 1.87. Please give me an answer. You can enter the answer in the chat box. Since I have got an answer, we'll see the solution now. So, as I have explained, it will be considered as 1 because it is pure solid. Same applies to pure liquid. When we say pure liquid like H2O or we say any aqueous solution, we will put it as 1. Here, because it is saying the concentration is equal to activity, that's why this curly bracket was converted to square bracket and we 10 raised to power minus 7. It was not 10 raised to power minus 7, right? It was 10 raised to power minus 1.87. Yeah, here they have corrected. 10 raised to power minus 1.87. And yes, your answer is very correct. It's 2.98. I hope you understood how we have solved this. This is the correct answer. Moving forward to next question. Such kind of question you will get in examination, and it is very clearly written. It should be correct to 2 decimal places. So this value should be very correct. Means what you can do, if you are getting something like minus 2.981, you can write this also, but this has to be very correct. You can round off the values as well, but round off to nearest integer if and only if they are asking to round it off. If they are not at all, or if they are not asking for it, just put as it is. You can put 2.981 also, no problem. These two values should be correct because there won't be any manual checking for your this solution. It is possible that it will be checked by a computer. Okay, so be very careful what the question is asking and how they want you to answer. So moving forward, question number 6 is a study that investigated the reaction of bisphenol A with hypochlorous acid, okay, revealed even if all the BPA reacted, BPA is bisphenol A, hypochloric acid would decline very less and could therefore be treated as approximately constant under the experimental condition. The rate expression can be described as this. So there are two reactants. One is say A or BPA, we will write BPA, and the other is HOCl. So this question is saying, even if in a reaction, if this BPA is completely finished, gone, converted to some other product, we will still see HOCl. Okay, HOCl is still there. So first think of it, what kind of reaction is this? Zeroth order, first order or second order? So first thing, this thing should come into our mind. So if the rate is dependent on one reactant, it is first order. If on two, it is second order. If it is not depending on anything, it is zeroth order reaction. So first this thing should come. And this line, it is giving us a clue what kind of reaction this is. If you can figure out that thing, then it is very easy to solve the question. It is saying the initial concentration of 0.3 micromole per liter, total this is total BPA, and 18 micromole per liter, total OCl at pH 8. And the Kf is this. How much time would be required to destroy 75% of BPA in this solution? Please try to solve this question. Take 4-5 minutes and just break down the question into parts and try to solve it. We'll see the solution in some time. First, identify what kind of reaction is this, then it will be very easy to solve. Once you identify the reaction, one of these things will be gone. So it will be very easy for you to solve the question. Please try to do that. mention in the chat box if you have figured out what kind of reaction, what type of reaction it is, zeroth order, first order or second order. As you can see, two solutions are there. It seems like second order, but second order is not the correct answer. So please let me know what kind of reaction is this. Okay, now see the solution, match with your solution. So the answer is 8.56 minutes. So now we'll see how we got this solution. So this is the rate equation. Initially A and B were given, but when we are solving the equation, A and B will be gone because there are no coefficients. So this thing is there. Now HCl is equal to OCl negative, and because they are saying this hypochlorous acid, that is HCl, has not changed, means decline is very less, and we have got OCl of 18 micromole, but they are saying hypochlorite has not reduced, means this is the reaction. H plus OCl negative. We know about 10 raised to power minus, we know the concentration of OCl, that is 18. And we know what is the pH? pH is 8. Means 10 raised to power minus 8. So H plus is 10 raised to power minus 8. Now the question is saying that hypochlorous acid has not declined. It means however OCl we are getting can be taken similar to HCl. Anyway, when you will add and 10 raised to power minus 8, it will be 18.00000 something, right? It means we can say take HCl and OCl as equal, which has been done here. So HCl we have taken 10 raised to power minus 8. Therefore R is equal to minus 150, this is given in question, 150 BPA into 10 raised to power into 18 into 10 raised to power minus 6. How we are getting this 10 raised to power minus 6? It is given in micromoles, and micromole is equal to 10 raised to power minus 6 moles. Micro, okay? Micro is 10 raised to power minus 6. That's why we are putting it here. And we got R is equal to 0.0027 BPA. What is R? It is rate of change of BPA with respect to time. So this is what we got. We have seen this equation, right? dA by dt is equal to minus Ka. So by looking at this equation, we can clearly say it is a first order equation, first order reaction, because HCl is not at all interfering. Okay. So now solving this first order reaction, by solving this by integration, we will get this solution, which is in this form. A is equal to A naught e raised to power minus kT. This is what we got. Now it is saying that BPA was decreased by 75%. So how much BPA is left? 25%. 75% is gone. So how much is left? 25%. So that is why 0.25 is coming. Then by solving this in our calculator, scientific calculators, we got this thing. That T is equal to 8.56 mils. I hope you understood the solution. Shall I repeat? Or shall we move forward? Okay, I think we should move forward, or if in case of any problem you can ask me in between also. So question number 7 is very simple. It's like I have given you example in the initial portion itself. Same question is there. Which of the following class of reactor can be used to model calculation of 5-day BOD of wastewater in a beaker in a laboratory? So what kind of reactor is the beaker? Plug flow, batch or completely mixed? Very simple question. Beaker is what? Plug flow like this, batch like this, or completely mixed with inflow and outflow. So this is A, this is B, this is C. What kind of reactor beaker is? Yes, very good. So the option is B. Coming to next question, consider the following reaction occurring in a reactor. A plus B is 2C plus 3D. Rate of reaction is R1 and 3C plus 2B rate of reaction is R2. This was done in class also. So what is the rate of formation of C? Means we want to find out net C. So just look at the C, how it is forming and how it is deteriorating. So C, R net is what? Rate of formation of C minus rate of formation loss of C. So how it is forming and how we are losing it. So please try to solve this question. This is very simple. Please let me know in the chat box what is the answer. Just look at the stoichiometric coefficient of C. Rate of formation will be positive and rate of reduction or loss will be negative. Just write them in the equation and look at the stoichiometric coefficient of C, because we want everything for C. Please write this. So this is the solution, 2R1 minus 3R2. So in the first, C is forming. Okay. So formation is R2, R1. Now we are seeing the coefficient is 2. So just put 2. And in the second reaction, we are seeing that C is reduced. Here C and plus B is converted to A, right? So C is reduced. So second part is R2. What is the coefficient? 3. Just very simple. There is nothing to think about it. Just do. Yeah. This is explanation also. You can see it from when I upload this thing. The next question is a numerical type of question. Keep your calculators ready and solve the following. A batch reactor is operating to treat toxic chemical X present in water. Now we are talking about batch reactor, means there is no inflow and no outflow, just reaction. So if you remember the equation, V dC by dt del J, such equation was there, right? So there is no J term because there is no incoming flow and there is no outgoing flow. Just sink term means reaction is there. So chemical X is present in water. The initial concentration of X is 500 milligrams per liter. The concentration of X shall be removed to a desirable limit of 10 milligrams per liter. So initial concentration is 500, final concentration is 10. Calculate the rate constant if the described limit is achieved in 10 days. Very simple question. 500 was there. We want it to be 10. In how many days? 10 days. So how fast the reaction should proceed in a batch reactor? Please try to solve this question and we'll see the solution in a minute. I will take 2-3 minutes to solve the question. I have written formula also. Please take the hint and solve this question. You need to integrate it to this limits. We will see the solution now. So answer is 0.391 per day. So how we are getting to it? When you solve this thing, then you will get by integration C is equal to C naught e raised to power minus kT. C naught is your initial concentration, C is the desired concentration, and K, you know the rate constant, you want to calculate the rate constant, and T is the time, which is 10 days. So C naught is 500 milligrams per liter, it is given. C is 10 milligrams per liter. Okay, this is also given. This is for the batch reactor. So 10 is equal to 500, A raised to power minus K into 10. When we are solving this, we get K is equal to 0.3391 days. Okay, so this is how we will solve this question. Now coming to the last question, which is a theoretical question, very simple question. Select the correct statement, and here also more than one option can be correct. So diffusion phenomena occurs due to concentration gradient. So as we know, there are advection diffusion, two types of phenomena. So when we talk about a river, it is flowing from this direction to this direction. If we are putting a ball here, in some times, plastic ball I am putting here, after some time the ball will move from this point to this point. So this process is called advection. Okay. And what is diffusion? If in a room I am standing at this place and I am opening a perfume bottle, or I am lighting an agarbatti, okay, incense stick. So if a person is standing here, this smell will reach to him, and this smell will reach to every corner. So this is what we call diffusion. So this is the question. So diffusion phenomena occurs due to concentration gradient. Advection phenomena occurs due to net motion of carrying fluid. And longitudinal mixing is considered in advection, and lateral mixing is considered in advection. So which of the following options are correct? Option C and D you will learn later very properly, but for now try to answer this question. About option C and D and this modeling approaches for the plug flow reactor, this you will learn later in the due course. At least try to get option A and B right. We'll see the solution now. So the option A, B and D are correct. So diffusion phenomena occurs due to concentration gradient. Means at this point the concentration is higher for the perfume, but here it is low. That is why it is reaching from here to here. In diffusion, anything flows from higher concentration to lower concentration. So that is what we call concentration gradient. If things are flowing from higher to lower in terms of concentration, that is called concentration gradient. Option B is advection phenomena occurs due to net motion of carrying fluid. So here river is flowing from here to here. Means what is fluid here? Water. So water is flowing from this side to this side. So it is taking this plastic ball along with it. So along with water the ball is flowing. So this is advection. Now option D is only lateral mixing is considered in advection during modeling of plug flow reactor. Okay, so when we talk about plug flow reactor, means this river. So this I am explaining, but this will be explained later very clearly. So we always considered a strip to solve such question. So in this strip, it is very properly mixed in this direction also. Which direction? Lateral direction. So this is longitudinal direction and this is lateral direction. So when we are modeling advection, means a flow from this direction to this direction, we consider a strip. I hope you remember the example sir gave, in which here the concentration was C, but here it was Z plus dz. So we have considered that this section is mixed very properly. So this is called lateral mixing. And why option C was wrong? Longitudinal mixing. So we never, in a plug flow reactor, longitudinal mixing is not at all there. There is no longitudinal mixing, because if here the concentration is C0, here the concentration will change to CF. So if there is longitudinal mixing, then there should not be any change between these two concentrations, but there is change. So that is why in plug flow reactor only lateral mixing is considered. So it is considered, it is an ideal condition if you are taking sample from here or here. In a strip, the concentration will be same, but if you are taking sample from here or here, the concentration will be different. So that is why there is lateral mixing, not longitudinal mixing. This will be cleared in due course. You will understand this properly. But for now, just keep this in mind. There is no longitudinal mixing in plug reactor, but there is lateral mixing. So this was the last question. Is there any doubt in any of the questions?
Madam,
Yes. You
Question number 9. Answer.
Yeah. Just a second. I'll go to.
so this slide.
Yes.
The answer slide.
Yeah.
That is just a minute.
Fine. Anyway, I will share all these slides with you. NPTEL is sharing, I think. You might have received the videos as well as slides of the last meeting. So if it is done, shall we close the session?
Okay, madam. Thank you.
Okay, thank you. See you next week.
Okay, thank you.
Thank you so much.